Hello, hello. Good morning, everyone. Thank you for joining us. We'll give it a couple minutes here as folks are finding their way into the Zoom room, and then we'll get going with this great panel discussion we have set up. Glad to see so many people energized after a long weekend, if you had one, to kick off the start of the week talking about the energy code. We'll give it a couple more minutes here, and then we'll get going. Okay, well, aloha and good morning, everyone. Thank you again for taking some time out to engage in this discussion on one specific aspect of proposals for updating the city's energy conservation code. As you can see on this first slide here, this is part one, and we'll have a little bit more information on how you can participate in parts 2 and 3, both tomorrow and Wednesday, respectively. But my name is Matt Gonzer. I serve as the director for the City and County of Honolulu's Office of Climate Change, Sustainability, and Resiliency. And I'll be helping to facilitate our expert panelists today and field your questions throughout. We have a little bit of background information, but we want to make sure that there is ample time for group engagement, because that's really the whole point, so that we can think through, and in this particular case, making it fit for Hawaii. So to start off, as I mentioned, my name is Matt. I'll be providing a little bit of intro and context. And as you can see here, our great expert panelists, including members from the private sector, city and state government, as well as an important partner in helping us think through how to capitalize on resources and other opportunities to cut costs and cut waste through grants and/or rebates, but really want to make sure that there's sufficient time for group discussion, to have the panelists riff off of each other, but also to field questions that you all as participants may have. So at any point throughout, please don't hesitate to put your questions into the chat. Myself and another team member from CCSR will be monitoring that. We might pepper throughout the panel discussion if there's a clarifying question, but we'll work to preserve most of the questions for that group discussion on the tail end there. So just to kick us off, really driving home the point that affordable housing is clearly the most urgent need in the market. People are probably acutely aware of a recent UH Economic Research Organization report that came out shedding light on the potential concerns around some of the state to county governing structure for how affordability and housing development and rules and regulations may influence people's ability to have a roof over their head. But we also know that there's a lot of ways that we can support improvements in energy performance while minimizing regulatory burden. And that's something that the Code Council itself is really keying in on these cycles of improvements, and something that we want to engage you all on, to think about what those kinds of incentives are, really thinking about performance versus prescription. How do we tap into cutting edge technology around modeling and thinking about being open and transparent in all of these ongoing discussions around code cycling, as we know they come up frequent. And there are ways that we can better prepare and engage and develop those relationships over time. And we also know that Mayor Blangiardi has really driven home the point that affordable housing is a top priority, and also thinking about really modernizing city operations, and not just thinking about the systems improvements that can and should be done within an entity like the Department of Planning and Permitting, but really iterating on all these ways that we can spark innovation, streamline opportunities, potentially incentivize different forms of development. And here's just a smattering of recent efforts through city leadership, either bills and ordinances, and thinking through how we can incentivize with money, provide support through reducing expenses like GET exemptions, find more ways to get more uses in different zones all around the island. That's a particular bill that is really exciting, called Bill 10, thinking about the master use tables in our different zoning districts, keying in on the challenges of short-term rentals in residential communities and making sure that those homes and structures are for our residents, and then thinking through development standards and incentives, and also another recent bill where we actually at the city deregulated parking and provided more incentives. And we know that there's more that needs to be done, and how can something like the Energy Conservation Code fit into this developing picture and strategy for affordable housing development? But we also know that conditions continue to get more and more difficult for development and construction over the past several years. Obviously, wildly volatile material costs. Recently, interest rates are creeping back up, which challenges the ability to get into a unit, perhaps. We know supply chain has been a real challenge, but also on the construction side itself, just electricity and fuel costs complicating crews, also challenges on labor and skilled folks out there to actually build the things that we know are critical. And all of this is operating in the same time where here on Oahu, we're coming towards the closure of our only coal power plant in September, while knowing that we need to bring more grid scale projects online, but also facilitate and provide the conditions for more direct power generation right above our heads, whether it's a residential or a commercial structure. And really the backdrop and the reason people voted for this office is that climate change continues to impact our local economy, our people in place, and it is accelerating in terms of different changes. And we'll be talking about one of those climate change impacts, heat specifically, as we progress. And the city, through both the administration and city council, last summer adopted our first ever climate action plan. And there was a specific action in there keying in on the importance of codes, which really helped to set the standard for new and future development. But the question really was put forward is, what is a better collaborative system or approach to achieving these climate goals while thinking about affordability in the here and in the long term? And that's really something that we've been keying in to do much more stakeholder engagement up front, recognize that code changes can be difficult, and it seems like they come up very frequent, and that can be a challenge. But we want to, through opportunities like this, really develop that muscle of engaging early and often and finding ways that we can all think about the same kinds of guiding questions and principles for whatever code amendments may be put forth. And I don't need to drill home this point. You're all quite expert in what these cycles are. What we are here to talk about today is local amendments for the 2018 Energy Conservation Code. People might think, well, didn't we just do this? Well, back in 2019, when that bill was introduced, Bill 25, that was to adopt the 2015 Energy Conservation Code with local amendments. We want to ensure that we're really thinking about the progress in these code cycles over their trajectory on improvements, and find ways that we can really engage stakeholders, the the experts in the building industry and development so that we can do this more collaboratively moving forward. And really to start with, we wanted to think about what is the purpose and intent behind the energy code. And you can see here, and Ben can talk about a little bit more moving forward, what we're seeing at the international and state levels is this recognition that buildings and the electricity that moves to them and across and in between buildings can really be an important asset for us to think about reducing energy costs, improving grid stability for the island as a whole. And combined, those are opportunities to not only reduce emissions, but really increase our collective resilience on this island. We know certainly it can be a little bit more singular when we're talking about any particular structure or building, but these are ways that we can find opportunities to partner to bring better benefit to the whole of the island across neighborhoods and communities. And this is one of the first proposals that we think is ripe for this code cycle update. And as I started, this is part one, and you can learn more at resilientoahu.org/energy code. I'll ask Alex to put that in the chat for us. Tomorrow, we'll be talking about different thematic areas around stretching our savings and then wrapping up with affordability through readiness. And really, as I pass it off to another colleague here, keying in on making it fit for Hawaii, we're going to talk about the concerns around increasing temperatures and heat shocks up front. We'll be talking about lighting efficiency and then other ways that we can simplify the code for our market. So with that, I'm going to hand it over to my colleague, Alex Yee, to just provide us a little bit more insight into what we've already experienced here locally in terms of increasing temperatures and some of the things that we know are over the horizon and that we want to ensure we are thinking about public health and safety through codes and through new construction. Alex?
Thanks, Matt. Hi, everyone. My name is Alex Yee. I also work for the Office of Climate Change, Sustainability, and Resiliency as the Coastal and Water Program Manager. And in that capacity, one of the things that I've been looking at is trying to get a better sense of what is climate change going to look like specifically here on Oahu. What are the impacts and hazards that residents on Oahu are likely to face? And I wanted to just share a little bit about some temperature projections because I think that it's critical as we think about potential changes, whether that's to how we build, whether that's to code, regulations, or incentives, to understand those potential changes in the context of the hazards and the amount of climate impacts that are probable to occur here. So I've put on this slide here just a projection of increases in temperature for the state of Hawaii that includes both some historical and also future casted projections based on emission scenarios. And so I've overlaid on this just the average typical lifespan of a single family home if it were constructed in 2020, so about 70 years, just to understand how much hazard we're talking about over the lifespan of houses that are constructed today. You can see that there's anywhere of a projected increase from 2.7 degrees to 4.5 degrees by just the mid-century, and towards the end of the life of the structure in the 2090s, we're looking at up to 9.3 degrees of increase. And in the by itself, it may not seem like a lot, but keep in mind that this is an average temperature increase, meaning that when we have hotter times of year, when we have especially hot days, when we have heat waves, that those are still going to be on top of these average temperature increases. And then just also to put it in the context of how it impacts residents, heat is actually the #1 weather-related cause of death in the United States. It affects so many people when it happens because you really have to be built to withstand it. If you're not, then it has a disproportionate impact on the elderly, on young people, on people with existing medical conditions, And I've put up on here a map. It's actually a section of a heat map that is actuals. So these were recorded here on Oahu in 2019. It happened to be the hottest day of the hottest year on record. And these are heat indices, meaning it's a combination of temperature and humidity, which is a better representative of the human response to heat and humidity. And as you can see, these high heat indices have real human health implications. And this is really a public safety and a public health issue. So when it comes to looking at these increases in heat, there is a lot at stake for Hawaiʻi residents. With that, I'm going to turn it back over to Ben to talk more about building envelope requirements. Ben?
Thanks, Alex, and thanks, Matt, for getting us started. So we're going to now dive into 4 separate measures that address this idea of increasing heat in the code. And really what they're trying to do is just trying to raise the floor on the code so that, although most contractors and developers already consider these items, we feel that there should be code in position to just assure that they're taken care of because of the liabilities associated with the increasing heat. So the first one is a measure that really is very much about the language of the code and the nuance of the code, and that has to do with the idea of unconditioned spaces versus conditioned spaces and low energy buildings. So in both the residential and the commercial portions of the code, there is exemptions from envelope requirements for low energy buildings. And the way that those are defined is by the term conditioned spaces. And so while that works in temperate climates, because we all know you're really not going to occupy a space very much in say in a northern climate, that you would, and that is evidence that that space is likely doesn't need to be insulated or whatnot, whether it's a shed or a garage or something like that. In Hawaii, it's a lot harder to define it that way because plenty of spaces can be built without conditioning. And so you end up in a position where the occupant years later may be in a difficult position to provide cooling. So this language is really just cleanup, and it's about switching this word condition to occupiable, which assures that the code, the energy code will be followed with regards to the envelope requirements. So one comment here, just for everyone who's attending, if there's a need for a clarifying question along the way, please go ahead and feel free to ask it. And then as we get to the end, you can hold your more substantive questions in discussion, and we'll have plenty of time to address those then. So next slide. So similar to the last provision, but a little more nuanced, this is about the use of jalousies and jalousie windows with regards to the building code. So the use of jalousies has to do, is something that is really common in Hawaii, and it has a long history. And where you have the opportunity for cross ventilation, it makes a lot of sense. But there's a considerable amount of compromise with the use of jalousies in that when you're in a space that is going to be mechanically conditioned, air conditioned, really difficult to hold that cooling in with jalousies. And so yes, you do get a lot of potential benefit from cross ventilation, but then you also get some negative impacts from when you do need to air condition. And so this measure is not saying that we cannot use jalousies. This measure is just saying what we don't want to do is use jalousies in a case where there is absolutely no opportunity for cross ventilation. And so really their negative impacts outweigh their positive impacts. And so we can go to the next slide and we'll see what we mean specifically by that with some clear examples. So you see on the left, this is an apartment, a one-bedroom studio, a one-bedroom unit on the left, and then a studio unit on the right. The one-bedroom unit, because of its exterior wall configuration, has the opportunity for cross ventilation to occur in the space. If those doors are open between the bedroom and the living area, then cross ventilation can occur, and you can get the benefits that are very real from jalousie windows, including their free area. On the right, you have a situation where there's very little opportunity for cross ventilation. And so this is a condition where we would say the code would disallow the use of jalousies, because effectively what you have there is a space where that unit door is going to be closed 95% of the time, if not more. And so it's a single space, and air pressure is just going to stop any airflow from going through the space. And so the code language is shown here at the bottom of the page, And it just makes it clear that, yes, we like jalousies when they're appropriately used, but there should be limits on their use. So next slide. So this slide is an important conversation. And really what we're talking about here is solar heat gain. So with masonry walls, I think we all know that masonry is a great material to be used in Hawaii for a lot of reasons. It's very durable. It's very resistant to high winds and storm conditions, lasts a long time. And it's got a real history in Hawaii of being a successful building material. And in fact, because of Hawaii's modest swings between daytime and nighttime temperatures, there's also not a need to have continuous insulation with masonry, because if you're talking about an indoor temperature and outdoor temperature that are only 10 or 15 degrees different, and you're also talking about a daytime and a nighttime temperature that are not very different, there's very little heat transfer that occurs through convection along that masonry wall. And so it's safe to say, hey, we don't need that continuous insulation. However, especially with east and west facing walls, we see the condition occur fairly frequently where you have a masonry wall that can absorb a tremendous amount of solar radiation in the form of shortwave radiation that will really heat up a masonry wall and just basically turn it into a radiator inside of a space. And that is something that can be prevented through either the use of reflective surfaces or shading. So projection factor of greater than 0.3 in this case is what the language is. And so what we're proposing here is to eliminate an exemption in the state code that exempts masonry walls from either the first or the second of these requirements. And that's, again, to avoid that heat that we know is going to just only get worse. So if we could go to the next slide. I'm going to pass it to my good friend Howard, and I just want to thank Howard for being here. Howard has been doing this work more than most of us can even claim to remember, and as a wealth of knowledge. So Howard, thank you.
Okay, greetings to everybody. Thanks for attending Howard Wigg, Hawaii State Energy Office. Been here since the Upper Pleistocene. And we're always looking at energy efficiency measures that will not only do the work of keeping the solar heat out of spaces, but be resource efficient and cost effective. And one of the best methods, especially in Hawaii, is to have reflective surfaces. Right now, we're just talking about reflective roofs. And you probably see an ad in the paper where there was a dark, rough roof, and it was coated with a white coating. The dark, rough roof was hot, 178 degrees. Put the coating on, it goes down to 103 degrees. Huge temperature difference. And that really is a almost natural way of keeping the heat out of a building. So in 2015, I participated in a national code, and we require for flat commercial roofs a certain reflectance for climate zones 1, 2, 3, the lower climate zones. And we've certainly brought that into Hawaii. Hawaii has the greatest insolation level, the solar incidence of solar radiation falling on us of any state in the union. So it makes real sense to require reflective roofs. And just like most other technologies, the reflective coating has been improving. So here we are proposing to up the initial reflectance and the agent reflectance. And it's cost effective. Go into any store, you can easily get this type of material. So thank you, Matt, for agreeing to have this really resource and cost effective measure into the code. Thank you.
Howard, this is you as well. So
this is me as well. I never would have guessed that. Like anything else, technology is improving. The best technology with the greatest improvement has been the LED, light emitting diode light. And what we're proposing here is to raise the minimum efficacy of lights, or not raise minimum, but assume that we're using very high efficiency lamps such that the lighting power density, the number of watts per square foot in a space, can go down, down, down. And to be cost effective, what we're proposing is if you get 80% of the light down, then you can eliminate certain lighting control requirements which cost money and which sometimes get disabled. So go down, take the code's lighting power density, go down by 20%, and you don't have to conform to the lighting controls, and you're guaranteed a 20% savings. And incidentally, when you lower the lighting power density by 20%, you lower the internal heat gain from the lamps by 20% also. Again, very, very cost effective. And incidentally, because the LEDs are so efficient, you can probably reduce the number of luminaires that you need in designing the light. More cost effectiveness. Thank you.
So now we're going to hear from Keith from Palco, and he's got some thoughts and some ideas to share with regards to masonry and reflectivity.
Am I on? Hi, everyone. I'm Keith Keto. As Ben mentioned, I'm the sales manager for Talco Incorporated, and we are the biggest manufacturer of concrete blocks in the state of Hawaii. And we've been working with Howard for several years now on the energy code. And I believe that 2019, when we changed the 2015 code, we put in the exemptions for concrete masonry based on several common sense reasons. Number one is, the main thing is, I believe, can we share that next slide? There we go. Okay, so I'm sure you guys saw the first slide when we're talking about a thermal mass and a concrete masonry that Ben shared with you folks. But this one, we tried to pare it down a little bit more to the Hawaii weather. As you can see, the temperature swings alone in Hawaii is very moderate, as Ben mentioned, probably between 10 to 15 degrees, changes between the coldest point and the warmest point. And as you can see now, when we look at the a non-insulated stud building, it kind of follows along the same temperature with maybe a slight about a 1 to 2 hour lag. Whereas you can see concrete masonry, we're looking at about 6 to 8 hour lag. So what's the really beauty about concrete masonry is, I think you guys mentioned about improved grid stability. That's where a thermal mass walls really plays a big part. It transfers the load from the daytime to the nighttime, which is very important, yeah? And that's how we're able to change the, I guess, the code originally on the mass walls. So I guess our major objection in adding additional costs to the masonry wall system would be how much would it really gain because of our moderate temperatures. That's why I wanted to show this slide. Very little temperature gain. And I know Ben mentioned the west walls and the west facing walls because of the heat, but you're talking about a very small portion of the house, and really, like, it's not like the roofs like Howard was talking about where you're gonna get a lot of sunlight reflection. Yeah, it's only on the walls in the afternoon time. And I'm not to say that SRI index is not true. It will cut back on the heat and reflection, but by the time the people actually fuse it with masonry and concrete, it'll absorb a lot of the heat. So the temperature, as you can see, according to this graph, will drop down, yeah? And like I said, and another thing I wanted to mention why we're kind of against the index is the cost. I don't think that a lot of the studies mention the maintenance costs. Painting always costs money, especially in Hawaii sun. And because you have two different total materials between a concrete and an acrylic paint, you always have to maintain that. And people have to repaint their houses or commercial buildings minimum every 20 years. Yeah. So that's another big added cost that is not taken into account in a lot of these studies. So whereas we always felt that that the advantage of natural masonry is, one, a long-term maintenance savings, because there's not really much you can do with the wall. It absorbs heat, it transfers all the grid loads. And another thing, it also helps with the carbon offset. Yeah, painting a wall will reduce its sequestration, which is the ability of a building material to then absorb carbon. Yeah, and the great thing about masonry especially is that it has a high, in its natural state, methane absorption rate. And taking that away from it, I think it's kind of like, when we put the whole total picture together, we're going to be a negative effect to it. And also, aside from the additional costs as far as new construction, but also the architectural and design costs will go up too. Because especially in commercial buildings, low-rise residential, architects kind of try to design a lot of things around that. And for them to get, and if you can bring up the next slide, I believe, as you can see, the ASHRAE code, ASHRAE takes into account the thermal mass walls and what is that, in its natural state. So it'll make it much easier for the architects to bypass and not having to hire consultants and whatnot for special buildings to get it through the code compliance. And that's why we kind of wanted to simplify the code back in 2015, yeah. To make it simple for the design people that they can design a very, what we call friendly and pleasant environment around the buildings without having to worry about having to use a specified materials in order to go meet the energy code requirements. Okay, that's all I got.
Thank you,
Thanks,
Keith.
Keith.
Now I'm happy to introduce Huang from Hawaiʻi Energy.
Hi, everyone. My name is Juan Tran from Hawaiʻi Energy. I'm one of the energy advisors here. And just to give you a quick overview of our program, Hawaiʻi Energy's mission is to empower island families and businesses to make smart energy choices and to save money and pursue a 100% clean energy future. So Hawaiʻi Energy has 3 areas of focus. One of them is clean energy technologies, all the equipment that you install, accessibility and affordability, also known as A&A. That includes small business owners, nonprofit organizations, and low-income residents. And we also have a market transformation, also known as workshops and education. So for clean energy technologies, our program encourages customers to install clean energy technologies through incentives and grants. For our A&A program, we have a team to ensure that all residents and businesses understand our program and can participate in our program. And then we have transformational, which is Hawaiʻi Energy coordinates professional development workshops and trainings across the island, especially for code training as well. So who can participate in our program? So anyone that has a commercial account or residential account on the islands of Hawaii, Lanai, Maui, Molokai, and Oahu. Kauai has its own co-op, so they don't participate into our program. So as you can see by the images on the slide, we have incentives for many measures listed here, like appliances, audits, retro commissioning. But there's one incentive that I wanted to point out specifically is our new construction and major renovation. What that does is it encourages building owners when they do a new construction or any major renovation is to build a model that's above code. A lot of times customers come to us and say, oh, do you guys, can we apply for an incentive? And they don't spec out an increased HVAC system because as you know, our program is based on the code, that's our benchmark. So anything that exceeds code is what we incentivize. So if HVAC systems go in or lighting go in and they just meet code, they don't exceed code, then we can't provide an incentive. So what this new construction incentive does is it rewards people to build models that exceed code. And our incentive is, believe it or not, it's $5,000 just to build a model for the designer. Then it's an extra $1,000 to the customer and another $1,000 to the designer just to present it in a room. The only thing you're doing is you're giving our customer another option of a more efficient building, and we'll incentivize that for them. So I just wanted to point that out. So it's a great incentive. Next slide, please. So as you can see, Hawaii Energy has participated in code trainings since 2018. I think we supported over 15 Hawaii State Energy Office training and code-related topics across the island. So we continue to do that and partner with the city to educate people and to enhance this initiative. Next slide, please. This is an interesting slide with statistics. The market analysis show air conditioning currently has much lower saturation in LMI homes. Increasing temperatures and reduced trade winds will force changes in the market and will result in significant increased energy burden for low and moderate income households. So that's something to think about as well. And I will hand it back to Ben. Thank you.
Thank you, Wong. And thanks everyone for presenting this information. So we have a little more information. If you could just go back, Alex, so I'd appreciate that slide that Wong was just presenting last. So this is really important. And what this is showing is it's showing the percentage of air conditioning across different homes on the island. And so you see the acronyms there. So single family homes, looks like RI stands for regular income. 68% of those homes have air conditioning, whereas single family, low and moderate income, 37%. And if you jump over to multifamily, MF regular income, 45%, MF low and moderate income, 20%. So with all this that we're talking about with increasing heat gains, we're very likely to see an increasing need across the entire building portfolio for air conditioning. And the end result, as is stated here and as Wong shared, is really increased burden, increased costs for those who occupy these spaces, because air conditioning is going from something that's been a nice to have to something that is becoming a need to have with increasing temperatures. So Alex, thank you. If you could go ahead forward. This is something that everybody appreciates. So this slide is really just about the things that we're definitively making easier in the code and easier to comply with and or less costly overall. And so Howard is very familiar with this first one and I think has participated in some of the analysis. So thank you, Howard. The analysis done for Hawaii indicates that there's really just not a need for floor insulation in residential construction for the purpose of keeping, maintaining temperatures. And so this is exempting our local code and our local contractors who are building single family homes from requiring R13 insulation in the floor. And so we're really happy to catch this one and happy to pick it up so that additional expense is not passed on unnecessarily to consumers. The second item that we're showing here is with regards to water recirculation pumps. And we've gotten some feedback from the Department of Planning and Permitting, and particularly their mechanical division, that said sometimes these pumps are really more difficult and more expensive than they're worth, especially in a case where you've got residential units and a really small circulation between the kitchen and the bathroom and the other fixtures. So just a short pipe run. And so that extra expense of having the recirculating pump doesn't really offer the kind of benefits that you might want. The third item here in terms of simplifications for the code, Howard mentioned, I'm just going to mention it again because it's really, really important. And that is because LED lighting technology is progressing so fast, it's our perspective that you can actually do as much in terms of energy saving with LED lighting as you can with daylighting. And so although daylighting is a wonderful thing and really creates beautiful spaces, the code is not here about the aesthetics of space. The code is there just to, this energy code, as we talked about earlier, is about resilience and about energy savings and greenhouse gas reductions. And since there's multiple ways to achieve that, we didn't want to mandate daylighting, because daylighting does cost money in the design phase and certainly in the construction phase as well, with the presumption of additional fenestration and a lot more thought into design to avoid additional heat gain and loss through the window fenestration. So amendments that really make a lot of sense. And I think that concludes the content side, but let me see, Alex, go to the next slide. Yeah, so this is an important conversation. So, I want to conclude here the presentation portion. We're going to have plenty of Q&A. Please put your questions in the chat and or be ready to come off mute if you want to discuss any of the items that have been presented. We really, really appreciate everyone that's on the call. Before we do go to Q&A, I just want to point out that this chart right here is really reflective of what's happening nationally, which is that the ICC and the national codes are all moving to zero emissions. And so this is not something that Honolulu is leading or choosing to lead. And we understand that this is going to be a challenging thing to do within the codes, but it's something that is necessary based on climate policy and based on what's happening across the world. And so what we are doing is we're really challenging ourselves. How do we collaborate? How do we work together? Both designers and regulators and contractors and developers to find the best ways to achieve this outcome. Sometimes in the past, the code has been contentious and there's been just two sides, and it's just been higher costs versus the need for regulations. And we really believe that we have to try to all work together and move out of that space. And so that's why we just continue to appreciate the diversity of conversation and just looking at where we have to go. We know that the only way to get there is to collaborate. So with that, I think we are going to go to the next slide, and there it is, questions and discussion. I'm going to ask Alex if she picked any up in the chat, and if so, then we can just put them up on the screen. But if not, we really welcome people to unmute and share your thoughts and questions at this point, and discuss with the panelists what might be important, what might be something that we can improve. So thank you.
Just confirming here that we haven't received any questions in the chat yet. Obviously, a lot of content, a lot of specifics as well for people to try to internalize. We're happy to provide and go back to any of the slides, allow any of the panelists to cover or clarify anything that they had. Or if you feel like you're better off trying to verbalize your question, please feel free to select the raise hand function and we will call on you. And while you're thinking through that, we have a first question from Alan Tam. Does the UH have some sort of prototype lab to test methods and technology? Any takers for that question?
This is Howard. The closest that I know of is the UH School of Architecture, and they have studied different efficient housing options, and they've dealt with the occupants of the homes and looked at behavior issues and which technology works, which technology doesn't work. That's as close as I know of. Thank you.
We have a question here from Deirdre. Can you discuss the timeline for adoption of these local amendments for the 2018 and then the future adoption of the 2021 Energy Conservation Code?
Matt, if you don't want to take that one, I'm happy to. And I know Howard will be able to jump in as well, which I will invite him to do as soon as I'm done. So I don't know if we could ask Alex to go back to slide 9, which we did skip. So we had a slide in our deck to cover the timeline, and we tried to save time and exit. But Alex, could you, oh, actually, I'm sorry, I can share screen. It'll make this a lot easier. Are folks able to see my screen right now with the timeline? Okay. So great question, and apologies for skipping it. We didn't know if we'd have enough time to get to everything. So we have been doing a lot of stakeholder outreach. This stakeholder outreach is really being concluded with these 3 meetings this week, and then we'll be pulling together any last feedback that we get and submitting an ordinance to council as quickly as we can. The aggressive timeline for that is to submit something in August, and then with hopes that it will go through and be ready to be implemented by November. So for awareness, for folks, the default to the state code happens in December, and so that's kind of our deadline and our backstop for trying to move this thing forward. And then I will pass to Howard in terms of talking about the next code cycle.
Let's see, where did Howard's?
You're off mute, Howard. We can hear you.
Oh, okay. 2021. Let's see. The way the code adoption process works is federal law requires that building codes, not just energy codes, all building codes be updated every 3 years. And the reason for that is that technology is improving so rapidly that we can build better, safer, more comfortable homes and buildings using better and better technology. So we meet every 3 years at the national level, reach consensus on which new proposals will come to the fore, and those are transferred to the state energy offices. Every state has an energy office. And in the case of Hawaii, the Hawaii Building Code Council debates any amendments to the national code and adopts at the state level. Then the counties are the people who enforce the codes and do the inspections. The counties have, after that, 2 years to adopt a new code with their own amendments. And this applies not just the energy code, but to all codes. And we are looking in terms of the 2018 at all the counties adopting by December 14th of this year, which is right about the same time that the state energy office, us, will be already formulating the proposals, state proposals for the 2021 IECC. And maybe we can adopt that by December also, so that the counties then have an additional 2 years to adopt the 2021. And just to reassure everybody, there's no radical changes planned for the 2021, just moving towards zero net energy. And we're doing a pretty gosh darned good job of that as it is. That's a preliminary answer. I'd be glad to do more detailed answers.
And Deirdre, just to shed more light on that, we coming into the new administration, recognizing the previous most recent process on updating Honolulu's local amendments, realized to Howard's point, we don't always have to wait, right? We can be a little bit more proactive in the discussions, help think through what the state is noodling on, engage experts, as Ben mentioned, across construction and trades, real estate development, and others, knowing where some of these code cycles are pointing towards. Howard's talking about the 2021 at the higher up level. They just a couple of months ago wrapped up some of the first discussions on the 2024 code in upstate New York, right? So recognizing that these cycles are regular and predictable, we have a strong interest in trying to get ahead a little bit and really think through more collaboratively preparing for it so that it doesn't always feel kind of truncated like we currently are presented with, but a little bit more open and collaborative moving forward. That's a goal. And thank you, Gail, for dropping in the links from the State Energy Office specific for these codes.
You're welcome. Thank you.
So it's Monday, and it's sometimes hard to come up with a question, but I just want to invite everyone, if you're on this call, your voice matters. We want to hear from you. And so please don't hesitate if you have a question. There are no bad questions here. We're trying to learn together about how to make these codes better. So certainly we don't need to take up extra time if people don't have questions, but we wanted to make sure we had plenty of time in case there were questions or even just discussion. It doesn't have to be a question. If you want to discuss one of these points, we welcome that. And while we're doing that, I will see if I can pull that link from way back in the beginning of the conversation to the 2 sessions that are happening tomorrow. And just remind folks that we have 2 more great panel discussions that are going to happen. One tomorrow morning at 8:30, that's going to focus on the stretch code proposal, a voluntary stretch code. And that's really about trying to provide incentives for developers to exceed the performance of the energy code as a baseline and really try to improve efficiency in buildings and show us the way in terms of high performance. And then on Wednesday, we're going to be talking about one of the provisions in particular from this round of amendments, and that is solar ready for commercial buildings. And that's going to occur at 3 p.m. on Wednesday. It looks like we've got a screen share up that just really shows you exactly how to register. I'll pass back to Matt.
Yep, Ben, there was a follow-up question from Deirdre. You know, we spoke about it in the intro of the session here, in terms of this concept of integrating best practices across modeling with the design process. You're more intimately aware of that, so please take that one away. And I'm providing here a link in the chat to this website, which we are showing currently, where people, if you are interested in the Tuesday session or the Wednesday session, or want to visit the recordings once they are done, all of that will be up at this website that I just put in the chat.
Deirdre, thank you for your question. It's a great one. So we definitely want to encourage energy modeling in the market. And the reason being is really because energy modeling is this great tool that provides choice for design teams, right? So instead of prescribing everything in terms of how a building is going to perform, the design team has the opportunity to model their building and actually prove that this is what the expected energy performance will be. So certainly there'll be additional discussions, and I know that there's other people on the call that probably have much more expertise than I do. But conceptually, we certainly want to encourage energy modeling as a practice in our market. Specifically tomorrow, this performance-based, stretch code, which is really saying, hey, if you can exceed the code by X percentage, and you can demonstrate that you're exceeding it via an energy model, then you can receive incentives. That's what the conversation will be about tomorrow. However, it will still be fairly high level in terms of the details of energy modeling. And so I'm certain that there's plenty of resources out there in terms of more specifically, giving guidance on how to utilize energy models, but that's not necessarily the intent of our discussions in the next couple of days.
Thank you.
On that same topic, Ben, and for the group's benefit, just sharing out loud Alan's comments about believes it would be helpful to develop statewide discussion to adopt common modeling platform to both facilitate designers and presumably on the review and permitting side as well. So just manifesting that by saying it out loud. And then I answered a question in the chat from June regarding the current EV readiness provisions in the city's code. That is a topic on the Wednesday panel around readiness, which really does have a focus on a new provision for commercial ready, but the concept is to carry forward the existing EV readiness provisions of the current city energy conservation code. Ben, correct me if I misstated anything there.
So one thing that did we share the results of the poll? So thank you all for taking our polls. We thought it was fun to integrate something and get a little interaction. I don't think there's anything revolutionary here, but I'm going to go ahead and share results. So I don't know.
I can go ahead and do it. Oh, you're doing it.
So this was the first question with regards to purpose. So it looks like 9 out of 10 who answered agreed with the broader purpose stated, and one did not. Stop sharing there, jump to the next one. Beat the heat. The question here, given increasing temperatures on Oahu due to climate change, how important is addressing heat gain in buildings through the energy code? So we're sharing the results. Very, very similar to the last set of results. And we'll stop. And then to the last one, achieving cost-effective climate action. So I'll admit that I think we might have been leading the witness on this one, but we're gonna, the question was, what strategy do you see as most effective to address our current building design and construction challenges? With the choices being moving towards zero emissions, resilient buildings needs to be the primary concern as the first choice, reducing upfront building costs as much as possible as the second choice. And then we need to collaborate in order to find ways to minimize costs while moving forward on resilient zero emissions buildings is the third choice. And there you have the results. So it looks like most people want to collaborate here, and that's great news because that's exactly what we think we need to do. And these are both really important issues. We can't in any way ignore the crisis that we have with affordability. And certainly we can't ignore the crisis that we have with climate change. And so the way to tunnel through here is to continue to collaborate and have discussions about how to solve these difficult challenges. So I think maybe that's a good place to stop. Unless there's any additional questions, we may be done. We may be able to give you back a little more of your day. Anything else? Last chance.
Maybe Ben, if you know, we had the last slide there. So Ben is our lead for this effort in partnership with the Department of Planning and Permitting. We're excited to be having these discussions with you. Ben is available to receive any follow-up communications via email so that we can keep people informed of both process and proposals. And then ultimately, when anything is transmitted, we want to make sure folks are in the know. Because to that last point, we greatly appreciate and benefit from increased and improved collaborative processes, and we're all in it together, so we got to do it together. Great. So with that, thank you again. The website there on the screen is where you can find ultimately the recording from this session, as well as sign up and register for tomorrow's session and Wednesday's session if you're interested, or share that information with your colleagues and follow up there for the ultimate recordings from those sessions as well. From myself and the team, just a big mahalo to our participating panelists from Keith and Howard and Huang, and Alex from our team for also joining in. And we very much appreciate all of you joining in the discussion today. And we look forward to continued discussions moving forward. So with that, other Alex G, we can stop the recording